Hello and welcome to the Code Magic channel. In this video, we are going to have a crash course into Pantsbuild system. You may find this video helpful if your organization is looking for a monorepo build system and you are evaluating Pants, or maybe you work for an organization that has already adopted Pants and you need to become familiar with the basics, or perhaps you're using a different artifact-based build system, such as Bazel, and you're trying to decide whether you should switch to Pants. Or maybe you're just curious and you would like to learn more about Pants or build systems in general. Either way, this course will give you pretty much everything you'll need to get started. We'll be using an existing Python project that doesn't have any build configuration enabled yet. Taking baby steps, we'll enable Pants features, gradually increasing the complexity of the build workflow. By the end of this video, you'll know the key concepts, how to create build metadata, and how to run Pants commands to lint, format, package, and test your code. Alright, let's get started. In a typical Python development process, you would create a virtual environment to be able to run and test your code. This is something we can do quickly here as well. So I've created a virtual environment and I have installed the necessary third-party dependencies to be able to format, lint, type check, test, and package the code. I have also activated the virtual environment to install the project in editable mode. And now we can run our entry point command from the local virtual environment installation. This simple Python project provides a console command that can query PyPI index for information about a given Python package and return the compatible versions. We can also test and package our code. For testing, I'll be using the pytest command. And for packaging, I'll use the python setup.py to produce a wheel. The build steps could be grouped by other tools, such as make, to be able to run them in batch. For instance, I could run make check to run formatting, linting, type checking as a single command. Now that we are familiar with this project, let's enable Pants and start working on the build workflow. We'll start by installing the Pants launcher on the machine. We'll download and run a shell script that bootstraps Pants for us. You would normally check in this file in the source code version control for security purposes, and also to make your build more reliable, as you don't want to depend on a file hosted outside of your monorepo. So let's run this command. If you are on a macOS device, you can also install the binary launcher from Brew. Now that we have bin pants executable, we'll need to make sure the bin directory is on our path. You could also create an alias to use in your shell, so let's do that instead. Now that we can run the pants executable, and because there is no configuration found, it will help us to create the initial one. So let's run the pants command. Pants has installed all the necessary files it needs to run, and have also created the pants toml file, which is where you'll declare most of the build configuration. You can also see that we get a warning about the telemetry configuration missing, so let's enable one. Note that we get some autocompletion and IntelliSense in our IDE. This is because the pants toml file JSON schema is published on the JSON schema store online, and many IDEs such as PyCharm or VS Code are capable of using this schema against various configuration files. After we have enabled the telemetry, let's run pants command again. Notice that warnings and errors, as well as inline code blocks, are highlighted in the terminal to improve readability. Let's copy the repo ID into the config file. Now we can also run pants version command to confirm we are ready to proceed. Now that we have pants successfully installed, let's see how it can be used. At this moment, we have the project source code, and we need to let Pants know about it. To tell Pants where the source code is, we need to declare the directories that correspond to the roots of the language package hierarchy. These are known as source roots. You can think of them as file system locations from which the import paths are computed. In our project, the sources are stored in a cheese shop directory, and the tests are stored in a test directory. This means we have the import path starting from the root of the repository. Let's take a look at one of them. Inside the source code, we have a from cheese shop import statement, and inside one of the test modules, we have the similar structure with the from cheese shop import statement. This means we can declare the source root to be the root of the repo. So let's do that. Most Pants functionality is provided via pluggable backends, which are activated in a Pants toml file. Our project is Python only, so let's enable this particular backend in the global section. Pants has very detailed documentation published online, but there is also an enormous amount of help available via the Pants help command. Let's run it to see what backends have been enabled so far. Most of them are not yet enabled. However, the one that we are interested in, the Pants backend Python, is currently enabled. The default Python interpreter constraints that ship with Pants would let us operate on the Python code automatically, but it's more favorable to explicitly specify the interpreter versions that our code is actually intended to run against. So let's do this. With this we say that our code is compatible with Python version 3.10 and above, up to version 3.12, which at this time hasn't yet been released. Now that we have enabled Python support for our project, we can actually start telling Pants about our Python modules. Pants commands are known as goals, and to be able to run most of the goals, Pants needs to have information about your code. For example, to run a test, Pants needs to know about all the source code a test depends on, and any testing configuration you may want to apply, such as a timeout, or whether a test should not be run on a particular hardware architecture. We declare information about the code via targets, which are an addressable set of metadata describing your code. Let's run the Pants list goal to list all targets in the project. We'll see that no targets are currently matched. The double colon notation is used to address all targets in the current directory recursively. Since we are in the root of the repo, this would include all the repo targets. As you can see, Pants is not yet aware of any code. To provide metadata about the code, we need to use build files. Build files are typically located in the same directory as the code they describe. Let's create a build file manually and add our first target to describe the Python source code. Here we have created the Python sources target in the parsing directory build file. Let's rerun the Pants list goal so that we can see the Python modules listed. Manually creating build files for all the directories may be rather tedious, so the generation of build files is automated. One can run the Pants Tailor goal to auto-generate the build files. Here we're interested in creating build files for the cheese shop source code directory and tests directory. Notice that Pants has created Python sources targets for the source code modules and Python tests target for the test modules. This is because by default, modules that start with test underscore or end with the underscore test are considered to be test modules. Keep in mind that there may only be one build file per directory. A Python source target would include all source modules found in the directory where the target is declared. The same applies for the Python test targets. Let's now rerun the list goal to see what source modules are available to Pants. Also, let's see what's inside a particular directory. You would likely want to run Pants Tailor goal with the check flag in your continuous integration server to ensure that Pants is aware of all the code being added to the repo. So let's do that. The command returns exit code 1, so we are aware that not all the code is known to Pants. The command suggests creating a build file to include the setup.py at the root of our repository. We won't need it to package our artifacts with Pants, so we can ask Pants to ignore this particular location. We are also not yet ready to tell Pants about the third-party dependencies that are stored in the requirements directory, so let's ignore this for now. We'll modify the Pantstaml config file. Let's rerun the Taylor goal to confirm there is nothing missing. And now we are ready to start interacting with these targets in the terminal. As Pants now knows about the source code, we can explore it to learn more about it. For instance, Pants provides the tools to query the dependency graph. Let's see what a particular module depends on. The dependency on costs.py and properties.py were detected, and we can see the import statements in the file. Here is the import from costs, and here is the import from properties. However, Pants cannot infer owners for some of the imports, since we haven't told Pants about the third-party dependencies of our project, which is something we'll do later. To build the dependency graph, Pants runs static analysis on the code to discover them. This may be picked up due to import statements or presence of string literals that look like a legitimate Python module. This process is called dependency inference. Because the dependencies are inferred, this means you do not need to declare the dependencies between individual modules manually in the build files, which is tremendously helpful. The third-party requirements that are currently ignored, as we haven't told Pants about our project requirements just yet, so let's reflect this in the config file. Let's modify our source code to see how the dependency inference works in practice. We'll add another import statement, so let's do that. Here we're going to import from exceptions. We'll also add a line that looks like a subprocess call to run a Python module via a Python interpreter. We'll also modify the build file to manually declare a dependency on a module that is otherwise impossible to infer from a static code analysis. Here we specify that package.py should depend on types.py. So this is going to extend any dependencies that are picked up automatically by the dependency inference. To enable inference of dependencies from string literals, we'll need to enable this feature in the Pantstaml config file. Now, let's rerun the dependencies goal on the modified file. We can see that our new dependencies were picked up. The costs.py came from the existing import, exceptions.py came from a newly added import, properties were here before, the query one comes from the string literal here, and then types.py is something we saw in the build file earlier. One can also query dependencies another way around. This is useful when you want to find out who depends on a certain module. Most often this would be the same as asking who does import from this module. Querying dependence of a module is also known as asking for reverse dependencies. Let's see who depends on this costs.py module by running another Pants goal. Asking for dependence shows that package.py and test_cost.py both import from cost.py module. Being able to operate on the dependency graph is essential to be able to perform operations only on subsections of your project, which is something we'll discover later. For instance, after modifying a source file, you would most likely want to rerun only relevant tests and not all the tests in a repo. Let's modify the CLI.py file. Upon changes to this console application, we would only want to retest the application itself, and not any of the business logic dealing with the PyPI index querying or data parsing. Pants provides a rich set of options to filter the targets in a variety of ways. Let's list transitive dependence of the modified file to identify what tests need to be run. For this, we'll add a new empty line to cli.py, and we can see the git diff showing us the modified files. Now we can run the change since flag, and we're using the git head state to compare the state of the repo with the git history. And we can see that it's only cli.py that's been modified, and transitively the test CLI are impacted because this module imports from cli.py. One can also filter the targets based on the type, a regular expression, or a tag. If the test modules are stored alongside the source code modules, we could ask Pants to list all Python test targets in a repo using this command. We can see here all the test modules present in a repo. If you are unsure how a module ended up dependent on another module, you may find the path goal helpful, as it shows the connections between two modules. For instance, you may be wondering why modifying a particular file would require running seemingly unrelated test modules. Let's find out how a source module and a test module are connected. Here we are asking for test CLI connection to the cast.py, and we can see that test CLI import from cli.py, which in turn imports from repository.py, and then imports from package.py, and package.py imports from cast.py. Now that we are comfortable managing and navigating the first-party code, let's make Pants aware of the third-party requirements of this project. How third-party dependencies are declared in a project varies greatly between teams and organizations. In this project, the Python requirements are stored in separate requirements.txt files, one for the local development environment, one for the local test environment, and one for the runtime. However, Pants also supports parsing dependencies from a PyProject TOML file, including the poetry managed sections. Let's update the ignored locations in the Pants TOML. And now we can add the Python requirements targets to the build file to tell Pants about our project requirements. Having these requirements added, we will now see the dependencies of source modules to include the third-party ones, in addition to the local repo modules. You can see the package py coming from the source code and the packaging Python package coming from external requirements. You may have noticed that when we ran the list goal earlier with the filter target type, we used Python test target, not Python tests. These kind of targets are known as target generators. For instance, Python requirements generate Python requirement targets for each entry in a requirements.txt file, so that we don't need to create one for each element. These generated targets have a special syntax with a directory name, then a colon, name of the target, hash, and then Python requirement name. Since Pants generates an individual target for each requirement, we can use them in the dependency graph queries as well. For instance, if we would like to stop using the Python datautil package, we can find out how many Python modules use this package to estimate the refactoring efforts. By using the dependence goal, we can find out what modules import datautil, and we can see the one source module and one test module. We could also find out if there are any source modules that rely on Python requirements such as PyTest that are supposed to be used only by the test modules. Let's modify a few sources by adding the import PyTest statement so they would be considered dependent on a PyTest package. To demonstrate advanced project introspection available in Pants, we could run the peek goal to output the build metadata in JSON format for further inspection. The JSON build metadata about all targets in the cheese shop package is piped to JQ, and the addresses of the targets dependent on PyTest are printed. Declaring rules to restrict dependencies in a monorepo is implemented in Pants via the target visibility rules, which we'll explore much later in this course. Most often, the Python requirement names are identical to the names of the imported modules. That is, NumPy package is imported as NumPy, and the request package is imported as requests. However, this is not always the case. For instance, the PyYAML package is imported as YAML, and the Python dateutil is imported as dateutil. Pants knows how to map the Python import statement to a Python requirement name, as it ships with mappings pre-created for most popular Python packages. If a package isn't included, you can specify the mapping manually as part of your Python requirements target declaration. Now that we have sorted the third-party requirements, let's try to run our console application using Pants. As an implementation detail, Pants is written in Rust and Python, but to run Pants, you don't need to have a Python interpreter on the machine. Pants Launcher downloads a standalone Python interpreter that Pants uses internally. To run your Python code, however, you will need to have on your machine a Python interpreter that is compatible with any constraints that you have set in the Pants toml config file. This applies to any other language that Pants support, such as Golang or Java. You need to have a Go and Java-C compilers accessible on the machine in order to be able to compile Go and Java code, respectively. We have Python interpreter available, so let's try to run our console application using Pants. For this, we need to use the run goal. To run a Python script, we only needed to provide the path and any arguments afterwards, but it failed to complete because a file wasn't found. When we have explored the Python application in the very beginning of this video, we had a virtual environment which I've created manually. This is where we had all the requirements installed so that we could run our application. In contrast to Python interpreters, with Pants, you do not need to manage any Python environments to run your code. The way artifact-based build systems, such as Pants, run your code is by using sandboxing. In broad terms, sandboxing is a permission management technique that isolates processes from each other and controls access to any system resources, such as file system. For Pants, this means that when your code runs in Sandbox, it has access to only a known subset of files copied from your repository. Let's rerun the last command, asking Pants to leave the sandbox on failure so that we could take a look inside. Let's navigate to this directory to take a look. When code runs with Pants, a file system sandbox is created in a temporary working directory that only contains known inputs such as source code, non-code resources, and information about known locations of any software such as compilers, Python interpreters, or system tools. Running your code in a sandbox makes the builds much more reliable. For instance, it's possible that your tests would pass when run locally because you have some extra Python packages installed in your environment, and those requirements are not declared in your official build requirements. However, this test would fail when run in a sandbox, which means you could catch the issue very early. In our case, the version.py Python module couldn't read the contents of the version text file because we haven't told Pants that this module actually depends on it. Let's take a look at the source code. Here is the version.py, and it attempts to read the version text file using Python. And here is the actual version file stored on disk. Dependency on non-code resources like this is difficult to infer statically, so we have to create a new target called resource and declare that it's used by Python sources. Let's do that. Here we create a new target, resource, give it a name project version, and specify the source to point to the version text file. In the Python sources target, we declare that this project version target is actually a dependency for Python sources, that is, for the module stored in this particular directory. Note that we have provided a custom name for the resource target. This is because, by default, the targets are named after the directory they are declared in, and you cannot have two targets with the same name. Let's rerun our script now using Pants. Before running your code, Pants pulls all the necessary first-party code and third-party requirements that are truly required by the code into a PEX file, which stands for Python executable. One or more PEX files are built and run in the sandbox environment when you perform any code operations, such as running code or testing it. We can also build a PEX file out of a Python script that could be run. For this, we'll need a new target called PEX binary. So let's create one. Having this declaration, let's use a new goal package to produce the PEX file. You can see here a new artifact has been written into the dist directory, which is a default directory where all the artifacts produced are stored. PEX file is just an archive with some extra metadata, so we can actually unzip it and look inside. You can see here inside the .deps directory we have all the Python wheels that have been downloaded from the PyPI index, and inside the cheese shop source directory we have our source files that have been copied from the repository. So here you can see all the required first-party code from the repo, along with the external Python packages that have been downloaded from the online package index. Having this single executable file is somewhat similar to a Go binary executable, which also contains everything an application needs to run, which is why distributing Go apps is so easy. Let's run our application. Now, by calling the actual PEX file and not the sources. Now, if we rerun the packaging command, you may notice that it completes instantly, as if it didn't run at all. That's actually true, since the source code and information about the third-party requirements that are going to be included hasn't changed, so there is no need to rebuild the package. Pants stores results of most operations in a cache that is used by default, and it is stored by default in the home directory. Fetching results of previous operations from the cache is what makes a build system like Pants very smart. For example, it can skip running tests if the code they exercise hasn't changed and the tests have already run previously. We'll see how this works in practice later. Now that we have been able to package and run our code, let's explore how running tests with Pants work. Traditionally, one would set up a virtual environment, install all the necessary requirements, and then run the tests. I have already virtual environment pre-created and have all the necessary packages installed, so I can just run pytest to exercise all the tests. I won't need this environment any longer, so I can just deactivate it. As I mentioned earlier, with Pants, you don't need to manage any environments, as Pants does everything for you. Let's run tests in a particular directory. For this, we'll need another Pants goal, test. Pants conveniently ships with pytest package, available internally, so we didn't need to provide any custom configuration to have our tests running. If we were to rerun the test goal for the same test, we would see that tests succeed instantly with the memoized status. So let's do that. As you can see here. As an implementation detail, Pants stores the results of some of the previous runs in memory, readily accessible by using a daemon, pantsd. Let's see what happens if we kill the pantsd process and rerun the tests. It takes quite some time to begin running the tests, since the Pants daemon process needs to start. Now the tests didn't run either, but instead the results of the previous runs were fetched from the cache. As you can see, it reads cached locally. When tests are run with Pants, they are run by default in parallel. If it is not safe to do so for some reason, for some of your tests, for instance for integration tests that interact with the same system resources, you can reflect this in the build configuration. You can adjust your test configuration either by passing additional arguments in the command line, or by modifying the Pants toml config file if you'd like the settings to apply. Here we ask PyTest to run a particular test case by passing the PyTest args inside a given test module, and none of the tests were collected. Pants also lets you group targets by setting tags on them. For instance, we could group integration tests under the test CLI directory. So let's do that. Now we can run the test goal only for those targets that have a tag integration set. At some point, you may also need to debug your code. You can use the built-in PDB module to set up a breakpoint in the test code and then debug it interactively, either in a terminal or in your IDE, such as VS Code or PyCharm. Let's do this for a given test module. I'll add the import PDB and PDB set trace inside a particular test case. And now we can run the test goal with a debug flag. In this mode, all tests are run sequentially, which may also help you troubleshooting issues when run tests in parallel fails. So now I'm inside the interactive PDB session. And let's try to run a command. So this returns an empty dictionary instead. I can modify the source code, and PDB will pick it up. If I continue execution, the tests now pass. Let's make PyTest show the test cases run when we run the tests in debug mode. For this, we'll add a new section to the Pants toml, specifically for PyTest. Passing -v for PyTest would emit name of the test cases being run. Now we can rerun the same command with the debug flag. As I won't need any of the PDB sections, I can just remove them. Now you can see when we pass the debug flag and we have the PyTest args-v set in Pants toml, we get the name of the test cases printed in the console. To explore how caching works, let's run all the tests in a repo. Now let's add a new test to the test costs.py and rerun the test goal. You can see that only test cases from the modified test modules were run. The rest of tests were fetched from the cache. So you can see all of them are memorized except for test cost. If for some reason you need to force your test to run again and you don't want to read from the cache, you can use the --force flag. So if I run a particular test module, I can see the status is memorized. And if I pass a --force now, I can actually ensure that the test is being executed without fetching any result from the cache or from the memory. If your repository is very big and has lots of code and lots of tests, it may pay off caring about the caching efficiency. Imagine you have a very large test module with 100 of tests. When you add a new test case to it, Pants considers the file to be changed and therefore needs to rerun all the tests, even though the results of previous test runs is available in the cache. If you would have 10 test modules, each containing 10 test cases, adding a test case to one of those modules would only require running the tests from this module. The results of tests from the rest of the modules would be pulled from the cache. So you would have 11 tests run and 90 tests fetched from the cache. Managing the dependency graph thoughtfully and being aware of the caching mechanisms may have a profound effect on the build time, but I'm afraid would require a whole different video to dive in. Apart from running, testing, and packaging your code, Pants also supports a variety of tools that do formatting, linting, and type checking. Let's try using a few of them. Because Pants uses sensible defaults for the build configuration, you can start using Python code formatters straight away. There is FMT goal, which stands for format, which can format your source code with black or YAPF formatters. We'd also like to lint our code, say with flake8. To be able to use these tools, we need to enable the relevant backends in the Pantsbuild file. Let's make some changes to a Python module so that we can get warnings from black and flake8. Now let's run the lint goal. Pants lint and pants format will consistently and correctly run all your linters and formatters. This means you don't need to remember how to invoke each tool or write custom scripts. This consistent interface even works with multiple languages, like running Python linters at the same time as Go or Java tools. These goals also run operations on files in parallel, which helps with the build time. Naturally, static code analysis and type checking can be run on files in parallel, whereas only one formatter may modify the file at a time. To avoid fixing the code manually, let's have Pants fix it for us. And this can be done with, well, you guessed it, the fix goal. We need to enable the relevant backend first. Now we can run Pants fix on all targets. If we rerun the same command again, you can see that Autoflake made no changes, and black didn't make any changes either. If we rerun our pants lint command, we can confirm that all the files have been modified and all the linters and formatters succeed. As with the PyTest, Pants comes with black and flake8 support among many other tools, so you don't need to set anything in the build configuration yourself. The version of these tools stay the same for a given Pants version. When you upgrade Pants to the next version, the versions of these tools may change. Most often, you wouldn't want to tie Pants upgrade to the upgrade of the formatters and linters. You can therefore pin the package versions so that Pants uses the same packages until you have decided to upgrade them. The files containing the pinned versions of your dependencies, transitively, are called lockfiles. Let's explore how you work with them. Lockfiles can be large and complex, but fortunately Pants will generate them for you. To start using lockfiles, we need to become familiar with the concept of a resolve. Resolve is a way to categorize your lockfiles when you have more than one of them. For instance, it may make sense to upgrade the requirements used by the console application, such as click or requests, separately from development and testing tools, such as PyTest or Black. You would also want to store log files in the version control, along with the requirements.txt files, if you have any. We already store the application and development requirements separately, so we can declare resolves in Pantsbuild. Once again, we create 3 resolves. One that Pants would use to create a sandboxed environment where it would run and package application code, another one when running tests, and another one when formatting and linting our code. Now that we have all three resolves we need, all we need to do is to adjust the Python requirements target to specify what resolve they belong to. Let's do this. So I'll navigate to the build file of the requirements directory. And you can see here we just added the resolve argument to each of them to specify what resolve each target belongs to. This is done to tell Pants what requirements.txt file should be used when generating each log file. To generate all three log files, one for each resolve, we need to run the Pants generate log files goal. So let's do this. This command would regenerate all log files. You can also specify the resolve which you would like to generate the log file for. For instance, you can choose to upgrade your application requirements a lot more often than your development and testing requirements. To regenerate a particular log file, you can run this command. We run generate log files, then we specify with the resolve option what's the name of the resolve they would like to regenerate log file for. Now that we have all the resolves, we can add any additional configuration for the build tools we'll be using. We'll do this first for black and flake8. So we specified for black, when we want to run the format goal, that we would like to pull this dependency from this particular target and this particular resolve. This requirements target, they point to a Python requirements target from the build file here. So you would do this for any tool you would like to have control over the version being used. For instance, we could add the isort and autoflake sections. Making sure we run tests using the same PyTest version is crucial, so let's extend the PyTest section in the Pants YAML file and ask Pants to install it from the test resolve. We can also confirm that our console application can be run. So let's run the same command we've used before. Let's also confirm that we can package our console application. Alright, having all the application requirements locked will also help us to ensure that only known packages can be used by the first-party code. Let's try using a new Python package in our console application code. We'll add the tabulate to the requirements.txt file and then modify cli.py. Now, if we rerun the application using the very same command that we used before, we'll get an error message, and it failed to resolve all requirements. You can see it's pointing to user requirements log file, and there is no candidate found for tabulate, because tabulate hasn't been resolved to this log file earlier. So Pants cannot find tabulate in the log file and stops. You wouldn't normally want to have the dependency resolution process when Pants pulls the required packages given a set of requirements to take place, as it's rather unstable. This is because if you run a resolve and then some time later, this could be next day or even after a few hours, you run another resolve on the same inputs, so same requirements.txt file, you may end up with a different set of dependencies. This is because new versions of direct or transitive dependencies may have been published between the two runs. Apart from the security aspect, this would also have a negative effect on the build correctness. For instance, you may start seeing tests failing, even though there were no changes to the source code, just because of another transitive dependency upgrade. This is why Pants offers a solution to these issues that ensures stable, hermetic, and secure builds over time. We have earlier packaged the PEX file from the PEX binary target. Having these PEX files built, you can include them into a system package or copy them into a Docker image that Pants can build and publish for you. There are other types of packages that Pants can produce, This could be an AWS Lambda, a Google Cloud function, a plain archive file, or a Python wheel, just to name a few. It's possible that distributing PEX files with all the requirements is exactly what you need, but if you want to distribute your packages to be installed into a Python virtual environment by your end users using, say, pip or pipx, you may want to build and publish a Python wheel instead. We have previously asked Pants to ignore the root of the repo when using the Taylor goal, so let's update this configuration, as we will be creating a target in the root of our repo now. Pants doesn't require you to maintain the setup.py file yourself, as it can generate it for you on the fly, straight from the build metadata. If your project already has setup.py, or if you'd like to keep it around to be used by other tools, you can ask Pants to use this file instead. Let's create the necessary targets. We have declared the Python sources target to include existing setup.py and a resource target to include the manifest file, which is used to copy any non-code resources. In the Python distribution target, we only had to provide the targets we'd like to include into the wheel. Because Pants infers all the dependencies from the targets we have included, we didn't need to manually specify all the packages transitively that need to be included, which is hugely helpful. Now we can package our Python distribution as a Python wheel. Let's do this using Pants package goal. Now let's install the Python wheel into a fresh virtual environment to confirm it has been packaged properly. I have a virtual environment already created, so I'm just going to activate it. And now I can install this wheel using pip. Let's see where cheese-shop query executable is. You can see it's inside our virtual environment directory. Let's run the cheese-shop query command that we have run previously when we used the pants run goal. And we get the results returned. If you'd like, Pants can also publish your artifacts to the online package managers. For instance, it can use Twine to publish wheels to a PyPI index, or it can also publish Docker images to a Docker or any OCI-compatible registry such as Artifactory or Docker Hub. In code bases with languages that have visibility rules built into them, such as Java, you already use the mechanisms to declare whether classes are visible outside of their packages using access modifiers. For other languages such as Python, you have to rely on conventions and agreements within your engineering organization, optionally writing some custom linting scripts and tools to help you spot prohibited imports to keep the dependency graph sane. Pants provides target visibility backend that lets you go beyond what is offered by any programming language, because it can let you operate on build targets rather than individual code members. For instance, you could declare that test modules cannot depend on each other, as making changes in a test module that any other test modules import from would require running the tests in those files, which is completely unnecessary. Or you could declare that no one should import from a standalone application, or that private modules in a shared library can be accessed only by a few public modules in this shared library. To see how visibility rules work in practice, let's add a rule in our repo so that our business logic code cannot import from the console application to keep the interfaces clean. As usual, we have to enable the relevant backend first. Now let's add a rule in the build file in the console application directory. Following each line in the declaration, we say that this rule applies to all files in this directory using a path star. We then allow our PEX binary target to depend on the console application as it needs to build the PEX file. We allow the current directory tree under CLI and tests under the CLI directory in the test directory only. No one else should import from the console application. Now let's add the violating import statement in the PyPI package parsing data module, namely types.py. Now let's list all the repo dependencies using the Pants dependencies goal. When we run this command, behind the scenes, Pants is constructing a dependency graph from the build targets and the graph dependencies are validated. Any errors or warnings found are then reported. We can confirm that our rule works as expected. As you can see, the types.py attempts to import Python sources, namely under cli.py. Now let's do something different. In another build file, we could also declare that our console application utils modules may only depend on click in terms of external requirements. Here we use the dependencies rule. We specify that this rule applies to all files in the current working directory recursively, and we only allow using click, so these modules can only import click and no other third-party requirement. Let's add a violating import statement in our source module. Here we add a click, which is allowed to be used, and then requests, which is not allowed. And again, let's evaluate our dependencies to see if there are any errors. And indeed, you can see the error message saying that utils.py attempts to import from requests, whereas click is acceptable. Pants provides the framework to author sophisticated and fine-grained rules to operate on individual files level if desired, but you can also declare the rules very coarsely to cover only the most critical parts of your codebase. For instance, that production code should never import from tests. In either case, you'll benefit from having a cleaner code architecture and a dependency graph that is easier to reason about. At some point, you may realize that there is no Pants goal that does what you need. Before considering writing a custom plugin, which is what we'll explore later in the course, it is possible that you may only need to configure Pants command line behavior by adding some command line aliases. You may also need to simply chain multiple Pants calls to achieve what you need. You can configure aliases using the CLI alias section in the Pants toml file. This new command will run tests that are necessary to run to exercise the modified files, including their dependencies, transitively. Let's modify a few different source files and run this new command that will find the tests that need to be run based on the changes we've made. Because I've modified only cli.py, only test cli.py was necessary to run. Let's reset the changes we've made to that file and make changes to another file and rerun just changed. Now you see casts.py are used transitively by all other source modules, therefore all tests needed to be run. You could also chain Pants calls in your console using pipe and xargs. Remember that you can introspect most of the build metadata using the peek goal if you'd like to query the build data in JSON format. For example, let's query the repo to find any resource targets that have been created but are not used by any other target. This is likely to be undesired. For this, I wrote a simple shell script. This script calls Pants to get all resource targets and then calls Pants again to find who depends on that resource. Let's run the script. As you can see here, a manifest file is being used by the Python distribution target we created earlier, and the version file is used transitively in a few source files as well. Now let's add a new resource target that is not a dependency for any other target. So there is a license file in our root of the repo, so let's add a target for this. And now we can rerun our shell script. As you can see, license resource is not being used by any other target, which is something we've been able to confirm. Pants can also be adopted incrementally. For instance, when enabling a linter across the repository, you may wish to skip linting a directory with legacy code. Over time, you'd like to be able to confirm that number of sources for which linting is skipped doesn't grow. Let's modify a Python sources target to skip flake 8. And now we can use the peek goal to pipe the output data into JQ to find modules that are not linted with flake 8. For this, we use the peek goal on all the targets in our repository, then we pipe it to JQ and use the JQ syntax to get all Python sources for which we have set flake 8 to be true. And we get the source location for each of them. You can see it's all of the files inside that directory. We normally set build properties on targets that include all or most modules in a given directory, but to highlight how configurable Pants is, let's keep flake 8 only for a single file and not the whole directory. This is something you can do with the overrides argument. So here we specify a file name and then any arguments we would like to override for that particular file. If we rerun our command again, we'll be able to see that only a single file is returned. There are lots of things that Pants can do that we haven't explored yet. In addition to the build steps we have walked through with you, Pants can also help you with code generation using Google Protobuf or Apache Thrift, managing Helm deployments, running shell scripts, generating version tags from Git, and a whole lot more. Pants supports execution remotely with remote execution, remote caching, meaning that you can configure your Pants repo to take advantage of dedicated build resources to be shared by your local NCI builds. Apart from Python, Pants also supports building Go, Java, and Scala code, as well as running bash scripts, building Docker images, with more languages and frameworks coming as I speak. It is possible, however, that at some point you may need to extend the functionality Pants provides. Perhaps you would need to add the support for another code generator or another type checker that Pants doesn't yet support. If this is the case, you can extend Pants by writing a plugin. The functionality of Pants that is available out of the box uses the very same building blocks that developers would use when writing custom plugins using the standard plugin API. You can submit your contributions to the Pants repository on GitHub so that it becomes part of the core product if you think the functionality is generic enough so that other Pants users would be able to benefit from it. If the functionality is very specific to your organization, it may make little sense to include it as a core part of Pants, so you will likely want to keep it internal to your company. Before writing a plugin, make sure to reach out to other users and maintainers in the Pants Slack workspace or file a GitHub issue. There are ongoing efforts to bring new functionality that isn't yet available in the official release. You may find that there are other users that are already collaborating on the feature you also need, so you may join forces. It may be also a lot easier to bring a feature into Pants core product instead of writing a custom plugin on your own, as you'll benefit from having code reviews and peer support. When you have some plugin functionality that you would like to make available across multiple Pants projects, this can be done by publishing this plugin to the PyPI or an internal private package repository. Macros can provide higher level concepts and reduce boilerplate in build files, but they won't let you create new targets or new goals. It may also be worth looking at the ad hoc tool target that provides you with the building blocks you need to put together a custom build workflow without needing to write and maintain a plugin. You can find more information about the ad hoc tool target and macros in the Pants documentation. You can also do some research to see if there are any plugins that others have shared publicly that you could use in your Pants repo. And to see how to use an external plugin, let's consume a community plugin that is published on the PyPI that lets us export the dependency graph data into a JSON. For this, I'll need to specify the name of the package that is published on the PyPI and its version. Having this plugin enabled, a new Pants goal becomes available to us. So let's run it. You can see there is a new goal dep graph that is not part of the core product, and this produces all the dependencies as a JSON format for all targets in our repo. As you can see, consuming external plugins is very easy. Writing a new plugin would require catching up on Python, but I'm sure this won't be a problem for any of you watching this video. It also often requires a good understanding of Pants internals, so you may want to pace yourself and start building something simple first. The Pants documentation features excellent tutorials on writing plugins. To get an idea what writing a plugin may look like, let's write a new, very simple plugin that would add a new Pants goal to list only third-party dependencies for a given target. The only thing we need to do is to declare where the plugin's code is going to be stored, and the convention is to keep it under the Pants plugins directory. So let's reflect this in the configuration file. We also need to enable our plugin as a new backend. So I'll add a line here. There is a Pants plugins directory, and that contains the requirements directory with 2 files. One is required to let Pants know where the logic is stored, and another file actually contains the logic. You're not expected to understand every bit in this file, but I'll walk you through just to expose you a tiny bit to the Pants plugin API. So we name our new goal, provide the help that users will see when interacting with Pants, and declare a goal function. Here it is. Pants knows that this is the rule that needs to be run when user will call Pants third party in the console, because this goal function returns third-party requirements goal. So this goal function will have access to the targets passed on the command line as targets object. And once you have access to them, you can start doing something useful. So we use Pants internal calls to fetch the dependencies of each target. We iterate in the for loop. And then for each dependency fetched, we print its address to the console, but only if it's a Python requirement, meaning it's a third-party dependency. Let's run this goal to confirm it does what we want. Just as with any other Pants goal, we can pass an individual file, a few files, or an address to a target. Let's start with a single file first. And inside the CLI.py we have 2 import statements, one for click and one for loguru. The rest is either standard library or first-party code stored in our repo. Now let's pass a few files. So now we got in the package.py, there are 2 more import statements. One is for packaging, another one is for typing extensions, which is reflected in our output. And we can also pass an address to a target. So here we ask Pants to work with all targets found recursively under the cheese shop directory. As you can see, there are quite a few. Notice that if we rerun the goal, the results are returned immediately. So let's do that on a single file. Because the sources haven't changed, Pants fetches the results of previous executions from the cache. If we add another requirement to our source file, the cache is invalidated, and Pants has to reread the file again. So let's add another import statement here with request. And now if I rerun this command, Pants has to reread the file as cache is invalidated, and we see the output in the console. So if you are just getting started writing plugins, take a look at the writing plugins tutorials and the documentation on writing plugins to get an introduction to the Pants engine core concepts. This is the end of this crash course. Thank you for watching this video, and I do hope you find it helpful. If this was your first exposure to Pants, you must be very excited now, as you've just learned the basics you needed to get started using a tool that will have a profound effect on developer productivity, build accuracy, and reproducibility. It is also possible that you feel overwhelmed and think that you will not need most of the features that I showed you in this crash course, and that's okay. Remember that you can always start simple and use Pants to resolve the most critical aspects of your build first. You can also visit the Pants blog to read about the case studies and how other organizations adopt Pants. If you'd like to learn more about the Pantsbuild project, visit pantsbuild.org and join the Pantsbuild Slack workspace. Thanks for watching, and speak to you later.